right, so what I will then lay out is brief intros, so that'll be a total of 5 minutes. Then we will just do any kind of like goals slash level setting very quickly, maybe 2 minutes. And then we'll do the main system design round, which will be basically 35 to 45 minutes. And then feedback, initial feedback, I should say, and basic like recap. How does that sound?
That sounds great.
Fantastic, fantastic. Okay, so for intros, let's do 1 or 2 minutes each. Of course, this is an anonymous platform, so feel free to disclose as much as you're comfortable with. Would you like to get started, or shall I get us started?
You can go ahead.
Okay, great. Yeah, so my name is Ivan, and I've got about 9 years of experience, mostly in machine learning engineer. And in big tech, I've worked at Amazon for a few years, and currently I've been at Microsoft now for a few years, so a bit of experience in large tech companies. And what else? Yeah, I've been on this site now for some time, both as interviewer and interviewee, mostly in the last months as a dedicated coach. So that's me. Yeah, how about you?
Yeah, I have been a senior software engineer for mostly on the full stack experience for like a couple of years now. I think it's been like 5 to 6 years. Before that, I was like doing more mobile stuff. But then when I came to work in the US, actually I started working for Amazon first. And then after that, I went to Meta, and then I found out that being a generalist is usually the way to go in the big tech company rather than like being siloed into the mobile space. And right now, I'm actually in a startup, but seeing now the job market seems to be like picking up for the big tech again. I'm planning to try to go back to the big tech company. And I think system design is probably one of the trickiest part of the interview, usually compared to the data structure algorithms. So here I am interviewing in the interviewing.io.
Perfect. All right. And so and thank you for that nice intro there. Sounds good. And I am watching the time. We're doing quite well. And in terms of goals level setting, you mentioned some hints in your intro. Would it be fair to say that we're targeting maybe like an L6 or L7, let's say, relative to Amazon?
I think in Meta it's like E5, so I'm not sure if it's like L6 maybe, but I think it's around there.
Okay, so let's say that. So I think Amazon and Meta levels are slightly different, but I'll say, or E5 Meta. Okay, great. So that is helpful. Fantastic. So I do have a system design question ready. And
Nice.
one thing that I'll actually note before we get started is two things. So one is if you've done a system design interview before on I/O, just so that we're on the same page, in the bottom left, there is a toggle whiteboard option. Have you had some experience with it?
Yeah, I've been using that one. Yeah.
Oh, okay, fantastic. So that's good. And then these are some general things, of course, we're tending to look for in a system design interview, general across levels, like E5 or E6, but we're going to pay special attention to some minor deep dives that we'll do in the interest of time, but just making sure that layout kind of makes sense. Any questions on that overall layout before we get started?
This sounds great. Yep.
Fantastic. All right, so I'm watching the time, and let us go ahead and get started. So here's our system design main question. Here we go. So take some time to read it, and we can get started.
Okay. Would you be okay if I actually copy this and bring it to the whiteboard?
That's Sounds good. Sure.
Mm-hmm. It's yeah, because usually I think it's easier to just like put all in like one page.
Mm-hmm.
Trade and execute. Okay, so for financial trading, design a platform where a client gives you trades to execute, and your platform executes trade based on available buy or sell prices from the market. Gotcha. So are we probably this platform sounds like a kind of like Robinhood kind of platform where basically creating a financial exchange trading app. So let me just like put it there. I'll write the functional requirements first. Okay. Do we need to implement the authentication, like at least maybe just basic authentication for the user, whether they can place a trade or not? I'll just write my assumption, and like if I need any clarification, I'll just like ask you. Would that work for you?
Yeah, and what I will say, and that's a really good question, is that for our purposes today, we won't focus on authentication and security.
Okay.
We'll actually assume that when we receive what the client gives us, in other words, trade orders, we'll assume that all security and authentication have been complete
Okay.
ahead of
Sounds good.
time. Mm-hmm.
Okay, so authentication is not in the scope. Assume it's already secure. And then probably we will be able to put order. I think in terms of the order, I know because I do a bit of stock investment myself. Do we need to care about the different kind of order types? Because I know there are like market order, limit order, stop loss order. Do we need to put that into requirements?
Excellent question. And yeah, and thank you for sharing that you have some background here. That will definitely help. So actually, yes, for each buy sell, we will assume for a little bit of simplicity, there will only be two types of orders. One is a market order that will try and fill, of course, as soon as possible. And as a complement to that, there will also be limit orders. And we will structure the limit orders in the best interest of the customer, in the sense, right, that if they say, hey, I want to buy 100 shares of Apple with a limit of 179, then we only execute that trade if we can find that volume at a price less than or equal to 179.
Gotcha. That is only if there's available someone is basically if you're putting a buy, then you need to have someone who's like willing to sell, basically, right? So okay, yeah, cool. Be able to buy, and in I guess in terms of, I mean, it's pretty good. Do we need to like be able to show their positions of the each user, or we just like strictly just trading part?
So it's a good question. The way I'll try and answer that is in two parts. One is we'll always assume that buy and sell orders are valid in the sense that if a customer says, 100 buy of Apple, we'll assume they have those funds always available. And conversely, if they are selling, let's say 1,000 shares of Apple, we'll always assume that at the time that we receive that order, they have at least that many shares to sell.
Okay.
And yeah.
Sounds good. Okay. Do we need to care anything at all about the UI side? Like
a little bit.
Yeah. So I mean, like for example, if they user like comes to Robinhood or like any trading platform, usually like okay, I want to buy Tesla stocks, and probably usually they only in the platform they just like show the price, the current price of the stocks, or they just like just maybe just display the bid and ask of the stock price.
Oh, yeah. In that sense, we will not worry about that. We're going to
Oh, okay.
assume that when we receive a potential trade to execute, that the client has already done their, due diligence. They already have all the information they need
Gotcha.
when they've,
So
yeah,
we do not need
given us the
no
trade.
need to display that basically to the user. Okay.
That's
Um,
correct.
yeah. Okay.
But one
Uh,
thing that I will add is, just briefly, is we will want to display to the user whether the trade we receive from them is pending, successful, or perhaps canceled.
okay. Mm. So either like pending, confirm, or like cancel.
Mhm.
Okay.
Right.
Yeah. Yeah, I think I have enough of the functional requirements. Pretty much the interesting part will be the market order and the limit order, I assume. So I think
Mhm.
if that is like, and we also assume that user does not need to search. Like from what you're saying, is that user already knows like what they're gonna buy and what they're gonna sell. There is no such thing as like, okay, I want to search for Tesla stocks and then like be able to like find the Tesla stocks and then like buy it, because like we're not displaying even the bid and ask to the user. Um,
That's
and
correct.
yeah,
Mhm.
and go to the non-functional requirements. Um, yeah, so I think it will be definitely highly available. Because for
Mhm.
any stock trader, I know for me myself, like I like to invest. I like to make it such that it really sucks when like I cannot buy or sell stocks at the point of like I want to buy and sell, because timing in the market is like really really important. That which reminds me of GameStop, where like suddenly Robinhood just like, okay, you cannot
Mhm.
buy anymore. That really really sucks. And that's like it's their choice. They're doing that. It's not the system fault. But that being said, I think
Right.
highly available is definitely needed. I think it definitely needs to be highly scalable. Just because like if I'm assuming that the system design that we're doing is gonna be something like Robinhood scale or like interactive broker scale, where there's like a lot of
Mhm.
users that's like using this. Also, like I think it needs
Mhm.
to be like consistent, or transactional. Maybe is probably the right thing to say, because like it's financial transaction, so you want to make sure that you got it right, and at the same time you do not. I would say like let's say you buy a Tesla stocks for 100 Tesla stocks, but then when everything is finished, then it's actually you only got like 95 Tesla stocks. So whatever that the order is actually being executed is not correct. So we do not want that. I think we also
Mhm.
want this is kind of like maybe latency is like probably we want to have a good latency, but maybe not like I think some high frequency trader like they really really require low latency. I don't think we have to go that far. But maybe something like for Robinhood, I'm pretty sure the latency is not uh, great in terms of the when they're putting the market order, as long as they hit something, because usually high frequency trader probably like they see one user like putting an order and then they're able to like front run it just because they have lower latency. But I think for in this case, probably the latency is not is low, but not like crazy low. So I think that would be probably a good non-functional requirement that we can start off. And I think like I just want to do a bit of like calculation in terms of the maybe in terms of the how many daily active users that you're thinking of. Is it maybe I don't know, maybe like 10 million daily active users? Would that be a reasonable estimate?
Yeah, 10 million, let's say max daily active users is a good start.
I see. Okay, max. So that would be like the worst case scenario. In terms of the I guess storage wise, if 10 million daily active users, usually I think retail traders they don't go crazy like putting like hundreds of trades per day, unless you're like again like an algo trader. I would say maybe at the most we could say that on average maybe like 5 trading per day.
So that's a good question,
Mhm.
and I liked your mention of interactive brokers. So let's make this problem a little bit more geared toward interactive brokers where there's flexibility. And let's assume that every day there's going to be some traders that are pretty low frequency, yeah, maybe 5 trades per day. But let's also assume that there's going to be some daily traders that are going to make up
Mm.
to 100 requests per second max.
Okay, so how about we say that this high algo, frequency trader will probably be like 5% of the DAU. Would that be actually a good estimate?
Yeah, I think that's a good start.
Okay, so I think like let me just bring my calculator. 0.005 times 10 million. That's like around 500 equals to 500K users of users high frequency. And I think this high frequency will probably like we'll just call it like maybe 100 trading per day for these high frequency users.
No, rather, let's assume that these high frequency users will at most do 100, they'll submit at most 100 trades or requests per second.
Right. Oh, trade requests per second. Okay.
Mm-hmm.
Okay. Yeah, I think if that is the case, like since the 100 QS per second compared to the 5 trading per day per user, we'll just calculate the one with the high frequency, because those are the one who is like very very quick. And I think in terms of the storage wise, so like we need to store the transaction data of each of their order and like what's executed and whatnot. So we'll just calculate based on that. So that's going to be 500K times 100, and this is per day. So I think 86,400, which is like per second. We'll just, I think in terms of the order code, I would, I don't know, maybe I'll just put it like around 50 kilobytes, just like an estimate. And I will let me just use Google Calculator to do this and to get a quick estimate of this. 86,400 times 50. That's equals to whoa, that's really really a high number. Maybe I will just, if I can do 500, and it's like, okay, so it's around 2.166, and there's there another like KB, that's basically megabytes. And I think if you divide it by 3 and 3, basically it's like, okay, giga, tera, peta. So I think it's around 216 petabytes per day. Yeah, I think this is, well, pretty much. I think like I don't think I have to calculate for the per user retail users, because I think I could, but I think this like the estimation of this would probably like kind of in estimation maybe I would just say like 250 petabytes, just like a do a quick estimation, maybe 250 petabytes per day. Yeah, so I think that is a lot of the I think that's more like on the transaction data, which is like a lot. So yeah, we have to maybe make sure that we account for that later on when we do this calculation. I mean, as long as we can do a horizontal scale, I think that's, in terms of storage, it's always like easy to scale. I think it's more interesting part, I think, about the financial transaction part. Okay. So with that, I think I'm gonna go to the whiteboard and then start drawing the diagram.
Sounds good.
All right, so I'll start with the user. And just call it like it calls the server. Oh, and I think I'll just write real quick of the API spec. Yeah, so I think will be like a create order, and the order I think will be in terms of the metadata. I think first we have the order type. I'll make it like super simple. Order type and maybe the ticker code. This one will be like Tesla or the TSLA or like BA, which is Boeing. And I think also will be the number of shares. Shares. And also I think will be I think for market order, basically you just like you don't have to put the number for the price, but I think for let's say for a limit order, then it's gonna be like limit price.
Right.
This will be like optional because like you could make it like obviously make it look a bit nicer, but I think basically if the order type is a market order type, then you buy whatever number of shares, or like it's if you sell, then it's gonna be you sell whatever number of shares. If it's it's a limit order, then you need to include the limit price, either what is the price that you want to buy, or what is the price that you want to sell. Okay.
Got it.
Yeah.
Sorry. And just one following order type, will that be either buy or sell?
Yeah. So yeah, good question.
Okay.
So my enum is I just want to actually make it like super simple. It's gonna be like market buy, market sell. Yeah. So it's gonna I know I can like put another like arguments there, but like I said, like I prefer to keep it like simple. And this is the more like implementation details, like how you want to do it. It doesn't really, in the backend layer, it's all the same. Yeah.
All right.
Okay. Yeah. Sounds good. So yeah, now I will just so put it here. I go to the server, and the server now will have to obviously reroute the logic. I think the interesting part here is like how do we make it such that the limit buy and limit sell is actually being done correctly. I think the first thing I had in my mind is that we use some kind of a Redis. I know that actually they are pretty good with this kind of like financial transactions. Let me just put this a bit below so we have a bit more space. Oops. Yeah. Yeah, I think Redis would be like a good fit. So I think Redis actually, like I read a little bit about it, and they actually really good with like a high write throughput as well. Especially that we have this like such a high throughput, so maybe one Redis instance will definitely not be enough. What are the ways for me to like scale that? We probably want to make sure that the Redis like maybe sharded across the tickers. That's like one way of doing things. Like we probably want to do something like let me just kind of rewrite it here. Like shard Redis across tickers. And we probably some tickers might be very very hot as well. Some codes that may not be very popular. So one shard of the Redis could have multiple tickers, but we should be able to actually make it such that if a certain ticker is like super popular, then maybe we'll just like reserve that one Redis for like that specific ticker, so that we can address a hotspot basically for that ticker. And yeah.
Got it. And Let me ask one brief question here. If we can spend maybe 1 or 2 minutes on the pros and cons you see of sharding across tickers versus, let's say, sharding across users.
I think the main problem with that is that if you shard it across users and like let's say if you want to do transactions, right? And if you have like basically if like user A and B, user A go to shard number one and user B go to shard number two, but then the Tesla stocks will be probably in the user in the instance number one, and Tesla stock in the instance number two might have different data, might have different like limit order buy and sell that's available. That would be a kind of a bad experience and technically not right because you want to make the market fair. In a sense that it's bad for the trader to like, hey, that trader actually he come in later, but he got a better deal when like my order comes in at the same time. Although it's not exactly like visible to the users, but I think that is a bad user experience in a sense.
Got it. Yeah, and that kind of makes sense with respect to your good bullet point on consistency. Okay,
Yeah.
cool. Yeah, let's continue.
Yeah, let's continue. So I think like the other thing that I want to touch on this like we need to obviously some persistence. This persistence could be like there are multiple ways. I know there's like Redis has an integrated CDC, or we can like so we can leverage that, or we can just do something like maybe a bit more old school. Is there's like we also send these loggings to the message queue over here. So we have like maybe like a message queue to actually like send all those transactions over here. And this one will be like a lot slower. So obviously we cannot like utilize this for like any of the updating the order status and like the how if the order is like filled or anything like that. This one we will not use this. This one is mostly on the like database that we're gonna use for persistence and also maybe for I don't know maybe data processing or something like that we want to do later on as a maybe Robinhood they want to aggregate all the data later on for their own purpose. So this one could be I mean I think we'll just like do something like a MongoDB or maybe if not MongoDB then I'll probably use Cassandra because I think I heard Cassandra is actually maybe it's still no SQL. But I think they are better in terms of like high writing throughput compared to reads. MongoDB, I think is more like, they can support, I think if you scale them enough, they can do this as well. But from what I heard that they're better as a high read / high write. So maybe something like Cassandra will actually be good for us to store like the logging transactions into Cassandra later on for it to be processed. And the one I want to touch on over, I think over here in Redis. So Redis is kind of in memory, and like the one I want to touch on is more on the limit order and limit cell. Oh, actually, yeah, this might be a kind of tangent to the functional requirement. For limit order, are we just putting the limitation expiration to just to be 1 day?
Good question. And yeah, for the sake of this scope, yes, let's just assume it's for the day.
Sounds good. Okay. Yeah. So I think if that is the case, if we are using something like Redis as like to act as a limit order and limit order like liquidity. What I mean by that is that from my understanding, Redis has some kind of like a sorted sets, or I think like a Z range. Yeah, it's not really on top of my head, but I think basically with that sorted set, we are able to like sort the order of both the limit buy and the limit sell, and be able to like put a sorting between of those ranges like of like the price of the. So when let's say the user sends let me just write this down. Like let's say example like sends limit order by Tesla 100 at price I don't know $200. So I think what we have here, we will have I think a sorted set here, to make it like, I think the way that they do it for like a game scoring, like a leaderboards. We can use this like data structure here to be inside the sorted set. So it's gonna be, Tesla, and then it's gonna be like 100 shares, buy at the price 200. That will be like inside the key maybe of like Tesla. The key will be Tesla buy, and then like 100 shares at $200. I think we're gonna sort it, I think, based on the price. So, and then you'll be like the volume of that shares is gonna be like sorted from like low to high. I think, sorry, it's gonna be sorted based on the price first. So let's say if I when you go put this order into the Redis sort of set, then I think they will try to find the one that goes to the Tesla as well, Tesla, and we'll find with the key maybe sell, and then we'll see that whatever that's probably if the price here maybe they have I don't know, $199 they only have 50 shares, but since it's sorted, then basically then we can like there's gonna be more sort of set over here where like maybe 100, maybe it's gonna be 201, and or maybe just 200, and that's gonna be, I don't know, another 50 shares. So when they like go to the Redis and like look into this, and they'll be able to like buy these two like blocks of limit sell, and then they'll be able maybe, and we'll just return back to the user as like usually I think interactive broker, like they usually say that, okay, you have fulfilled order at the average price of such and such, which I think maybe I should describe that a little in the API spec. So it will be like return, it will return order, maybe like the status, average price field, or so on. If obviously, if like let's say in this instance where the buyer they decided to like, okay, I just want to buy at 198. In that case, is that this will not, the limit sell is not going to be hit, because like when you see the Redis, it's like, okay, or there are only sellers who are like willing to sell it at like 199. So what is going to happen is that Redis is just going to put it there as like a buy in the buy limit order section sets of the Redis, which we're going to put it in like Tesla, and then like we're going to put buy 100 shares, and then we put the price there as like 198, and then that's going to be sent back to the user as the status is going to be like I guess pending, so I think I'll just put it here like pending field. And I think canceled if you want to maybe try to cancel. And I guess if that is the case, sorry for me going back and forth, but yeah, you might need to be able to cancel order as well, which I think maybe we're not really touching the functional requirement, but I think that makes sense. I think we should have the order ID. There you go. Cancel order ID. Yeah. And then we'll just return back the same thing with the same that is going to be canceled.
All right.
Yeah.
And these are good points. And maybe just one note, we're not designing the exchange, so to speak, just in case you were going on that path, in the sense that, we'll interact, of course, with, we can assume, one existing exchange where we can always say, hey, I've got a customer that wants to buy 100 at 198. Can you fill it or not? And then we'll get a response from the market that says yes or no over time. And Also, yeah, we do want to make this somehow asynchronous as well with respect to users.
Yeah. Yeah, I think good question, good call out. Yeah, I think if that is the case, then usually then we'll just like, okay, yeah, because my thinking that if we use Redis, that's like pretty fast, we should be able to fill it
Mm-hmm.
immediately if we cannot find it. I think that's if we're not able to, if it's not fast enough, then probably before we gonna be, well, let's say we could have another message queue to like maybe do asynchronous. We could just like maybe return immediately as like, well, I think we could like return the order as like pending first immediately from the
Mm-hmm.
server. And then like instead
Right.
of like we call the Redis, they call the Redis here directly. Oh my god, my bad. It's kind of small. So we could have something, for example, like this is gonna be like a bit isolated. We just have call it like transaction service. So we could have a message queue that actually like, okay, this message queue will be the one to actually like one, it goes to Cassandra, another one just goes to transaction service.
Mm-hmm.
This way, I think it's a little bit more, it's a bit lower latency, but again, like I think we have just described it that maybe we do not need like a super, super high frequency, and this is like for retail platform anyways. This transition service is gonna be the one to like, okay, we're gonna try to go here and like try to to fill the order. And if we are able to fill it, then we'll just like maybe tell the server that okay, the user actually has filled the order. I guess like one like
Mm-hmm.
it could be like we just go to message queue. And this one usually like if you're Robinhood like or Interactive Broker, I think Interactive Broker doesn't really have it, but if you have a Robinhood, you'll be able to like go to a notification service later on, like notification service. This could be something that connects to the Apple push notification service, and that would be like go to user. Um, that being said, like I know there are people who are like staring at their app, all the time
Mm-hmm.
to see whether the order is filled or not. So we could utilize notification service as like a way for them to like know that notification is filled or not. Or we could also have a WebSocket that we can like connect them to the server so they can have immediately that feedback of like, oh, there is your order has been filled or your order is now or still like pending. So that will be like a lot faster for them. I can add that over here if that's something that you are interested in as well.
Yeah, and you anticipated one of my questions here, which is the trade-offs that you see between drawing this arrow from basically transaction service to message queue to notification
Mm-hmm.
versus having an arrow that goes from transaction service to
Yeah,
server to
yeah,
user. Mm-hmm.
yeah. So I think that's like yeah, if like we use WebSocket, we can definitely do something like okay, immediately you go back with the use WebSocket here as well. The pros and cons is like one pros for using WebSocket is definitely lower latency, and lower I guess a better user experience in general. Doing for the message queue will be it's still functional and available as well, and you will still eventually get it, but you just maybe yeah the only downside is that let's say you buy Tesla stocks for like one okay
Mm-hmm.
200 shares at the price of like 200 and it was there and but the order that you see is still like pending and you kind of got you mean as a user you might got impatient and like what, I'm gonna try to cancel this and I'm just gonna like change the limit order to be like 201 or 202 or something so I can get it filled. And what can happen is that oh the order before was actually filled and actually this happened to me one time when I was investing.
Mm-hmm.
uh, the order before was filled, and then because you try to create a new order, you try to cancel it, that didn't work, and you try to like create a new order, that would be a problem because now you bought 400 shares and now you pay extra commission fee if you're gonna sell it again to the broker. One thing that you can like try to minimize this, at least in terms of the modification, is that we can use something like an idempotency key. So let's say when you put the order, right? You put the order to the server will hash it out in terms of like the order ID here. Maybe we can, I guess, use it as the idempotency key here. And then when you buy the 200 shares of Tesla, and then sometime later on you want to like, okay, I want to change it. Then maybe you can using the idempotency key, then you maybe that request will just fail. It's just like, okay, you already buy it, it's already filled. We will not allow you to buy another one. So I mean, just that's what you want to do. But it's a different story if you try to create a new order because you get impatient. In that sense, using WebSocket is better. At least we minimize that latency. When you buy and like you got it filled, then like you immediately be able to get the feedback and like you're not gonna accidentally create a new order. The cons is that it's gonna be more resources. Because of especially we have a lot of like throughput here, a lot from the high frequency trader. And that will require you to create like multiple WebSocket servers, add more complexity in terms of managing the which user is gonna connect to which WebSocket server, which is not impossible, but just adds more complexity. But yeah, if that's like a hard requirement for the user experience, that can definitely be done. I think in this one current system design, at least we got something functional, and maybe we can still minimize the error from the user side.
Got it. Thank you. Yeah, I think those are good pros cons on the utility of WebSockets, but also the added complexity that they bring. And basically, in the remaining time, let me ask about two topics. The first one is a sort of follow-up on WebSockets and how users are interacting. And my question is, how will you handle load, let's say at peak times, maybe, if we assume there's going to be a lot of trading in early morning, like 9:30 a.m. Eastern, and maybe a lot of trading peaked at near market close, like 4 p.m. Eastern or so, but maybe not as much trading, around lunchtime. How would you go about handling peaks in transactions per second?
Yeah, good question. I think I would probably add a load balancers, probably somewhere between here. That's gonna use a load balancers over here. And again, I think like we previously touched on, like, hey, we use a sharded key, shard, for each of the ticker. I think that idea can also be used over here, or maybe either that, or we just make it simple. We just like scale up the server over here with just like a round robin algorithm, or we just use some kind of like consistent hashing using the user. I think in this case it's okay. We use the user, maybe user ID and like the buy order, for example, it's like, and ticker code as like consistent hashing that you can like scale up over here so that it can handle the throughput. And then we're gonna like, I think for the message queue over here, I think this is the part that we want to make sure that we can scale it up as well. Again, I think how we can like, this one is gonna be like the big bottleneck over here. If you want to just like keep one message queue, we probably want to like separate the message queue into like multiple message queues. And like, again, the other way of doing this, I think, will be to make it like, I think, align with the transaction service. I would probably just use something like per ticker, or like maybe a combination of tickers of like the low volume ones, but the one that's like high volume will probably be like something like Tesla will probably have its own message queue. And probably we're gonna want to make sure that we can have an auto scaling cluster as well. And I think most of the AWS SQS, they have an auto scaling cluster that we can deploy, or we can just manually schedule that, like, before maybe half an hour before the market time. We just like calculate what is the maximum amount of QPS that's probably gonna be, going to the each of the service over here, and then we'll scale it up so that all of them can be can actually do the transactions. Redis, I'll probably be a bit less concerned, because like I know that I think from what I read in Redis Enterprise, they can go up to 2 million query per second. So that's, which is like very, really high compared to our like QPS, even with the highest frequency trader. So that one will be probably something I'm less worried about. It's mostly on the transaction service and the message queue, and then the server. Over here, the Cassandra one, I think should be fine as well to shard it, maybe a couple of them, but it's because this one is more like kind of like a data processing, like post-processing transactions. I'm not like super concerned about it, as yeah, unless whatever machine learning that we might have to do overnight, since like market time is only like 9 to 5 and then you're done. We do not need to like create like a big multiple like consumers to consume the message queue like fast enough, at least for the Cassandra part. And I think that should be doable.
Okay, cool. Yeah, and thank you for that. I think load balancer makes a lot of sense, and I like what you mentioned on auto scaling. So let me ask my basic last question regarding the topic on a database. So my question is that we do want to store some history of the orders that we received and whether they were filled. And yeah, in principle, we could use something like Cassandra. And my question is, were you thinking of a NoSQL or a SQL setup to store the records of these transactions?
I think like I was thinking both with the SQL and NoSQL. I think like, to be honest, like over here, we can definitely use SQL as well with the transactions. Although from my I think Cassandra also definitely supports transactions as well. And both, yeah, since both kind of do it transactions, so you can like do either one. Right now, because of technology like MySQL, for example, I know PlanetScale uses Vitess to do their like to be able to scale whatever like how amount to throughput. I think Cassandra is just kind of like the old school way of like NoSQL way of like high throughput and still able to have the good transactions consistency. I think the only part, if I really want to go for like a MySQL, is that maybe if we're doing something like maybe a payment between users like Venmo. Maybe if we need to have something like, okay, a metadata of user has friends with this guy, and then you need to do some kind of a transactions, and like you want to you might need to have like kind of a table join of transaction between users. That is maybe the good point of us, like maybe we should use maybe some kind of like a MySQL with a Vitess of technology on top of it to make it like scalable. But I think in this scenario, since user and orders is like, we have a very simple relationship between like users and buy and on the orders, and there's no like, like we don't have like a graph kind of network like spanning like social media. I feel like Cassandra is probably a better choice. And yeah, I think the only consideration then in terms of NoSQL is either we can choose like either Cassandra or like MongoDB. I think from my understanding, Cassandra, since it's the formatting of the table formatting is like column formatting instead, so it's like faster in writing, so it's better for writing high throughput compared to like MongoDB, where they are more like JSON object, and it's easier to read and scale, but not so good with just writing. Although maybe MongoDB is like maybe easier for like most people, engineers like to develop on, because it's more user friendly compared to Cassandra. Yeah, I just feel that's why I think Cassandra will probably be the best fit for this one.
Got it. Thank you. All right. So I think we're at a good overall stopping point. I'm just checking the time, and yes, I think we did well on time. Cool. So if you're open to it, let me take maybe 3 or 4 minutes for initial kind of high-level feedback,
Sure.
and then we can, and I'll incorporate kind of like a recap there of what we covered, and then I do want to make time in case you have some comments or questions for the last, few minutes of our time today. Does that sound good?
Sounds great. Yeah.
Excellent. Cool. So yeah, as a recap, I think we covered a lot of ground, right? The functional requirements, non-functional, and calculations, especially on the API spec. I think that was one of the highlights in terms of what the user should expect, in terms of what they need to give us, and also in terms of what we need to provide to the user. And we also got through the main diagram. So on those points, covering a lot of ground in terms of breadth, that was really good. In terms of depth, I think you showed a lot of depth on distinguishing, let's say, between WebSockets and the message queue. For me, that was a highlight, especially given the complexity of the problem, right? That on the one hand, we have users that are, maybe just going to make or submit 5 requests in a given day versus other users that might submit, 100 requests, per second, and that can really add up. So those were some highlights there. And I took some notes. The one nitpick that I would make is kind of halfway through the design here, we jumped a little bit back and forth between the API spec and some things that you were writing down. And to be honest, I think a reasonable interviewer will kind of assume that's natural sometimes, right? As we develop the system, we might say, hey, by the way, now that I've got this building block, let me come back to the API spec and add some things to it. So I think that's perfectly natural. A reasonable interviewer should not ding you for points there, in my opinion. But if after, let's say, going through functional and non-functional requirements, if there's an opportunity for you to say, hey, let me spend some time on the data contract and API spec and make whatever simplifying assumptions you need to get those APIs basically down, then it might be easier to design the overall flow afterwards so that your flow is kind of restricted in that sense, right? So that's one suggestion I might make there. And also, it might be a bit of a nitpick, but interviewers will differ on the following, is with respect to what we want to store or write in our database, that might be another place that you want to include perhaps in your functional requirements, right? Is we didn't touch on it directly, but implicitly in the UI, we said, okay, we are going to be a bit sparse or Spartan with respect to what the user sees in their UI, but as we are storing their trades, we might raise the question like, okay, as a user, let's suppose that today is Monday, and then tomorrow, Tuesday, maybe before the market opens up, I want to get a record of everything that happened yesterday on Monday. Right. And how would I do that? Well, if I made a simplifying assumption on my API spec, then a SQL approach might be good to do, because then when the user queries our system and says, okay, here's my user ID, here's my time range, now give me all of the records that happen, basically a columnar setup might be simpler than something more robust like a topics handler, right? Sometimes Cassandra or other NoSQL options can shine when we're considering things like topics, and we might store, documents of varying length. But in this case, we could make the assumption that we're going to say, hey, we're going to be very atomic about this. And our primary sort key, if you will, for lookups from the user perspective will be the user ID, followed by, let's say, like a time range. And that'll be kind of sufficient. So that's kind of just another nitpick there. Like I think we're preferring Cassandra, which is totally fine, but if there's time in the interview, say like, hey, limited time, I went with Cassandra, here's why, but another way, if we were restricted to using SQL, here would be, one way to do it, and my primary key would be, let's say, order ID or user ID, something like that to give a complementary sense. So that's my initial high-level feedback there. And finally, I would say, again, maybe a nitpick, maybe more important for others, is on fault tolerance and load, right? So we did touch on a load balancer, but sometimes it's good to consider like, okay, I've got this load balancer. I know things are going asynchronously, and I'm sending trades from millions of users. But what happens if a node in my server goes down? How will I handle it? And there you can get into things like, well, from the user perspective, right, I want to make sure I keep or store that order somewhere, but maybe I can rely on some redundancy or some multi-geography things such that some other node in my server tries to match the order with a market. So that's one thing to maybe keep in mind when we're talking about load and load balancers is, great, I'm able to handle all this traffic, but what if something like a node goes down? How would I handle it?
Like a zookeeper, basically, to like keep track of the health checks of each of the instance, and we can able to like replace the instance with the another instance that can have the copy of the data. Yeah.
Exactly. Things like that. And that can also kind of tie back to the database, right? Like if we can store things in a kind of good fault tolerant way in our database and then have our nodes interact with it to go to the market, that could be another discussion point. But anyways, pretty big problem that I provided, and that's my initial feedback there. Any questions or comments from your side?
Yeah, I think just a question. Do you think this will be a pass as an E5, or like do I have to, I guess like for that other, I think things that you touched on just now in the feedback, is there something like crucial for me to pass the interview?
Yeah, for E5, I think I would lean towards yes. And I think to get to a, let's say, even clearer yes, is some of the generic things that they sometimes look for in E5 and system design, which you touched on in the non-functional requirements, like highly available, highly scalable, consistent. What I would recommend to cover those bases is basically, once you've got a simple API spec and maybe some of the building blocks, not necessarily all of them in the design flow, then you can say, hey, interviewer, I've got these 4 things in my non-functional requirements. Which of them do we want to double down on? Can I double down on, let's say, high scalability? And a good interviewer would say, like, yeah, definitely, let's do that, or they might pick something else, so that you can then really demonstrate, and as some people call, show off maybe, on your knowledge of like load balancers or things like that. So that's one thing I might suggest there. Yeah.
So basically, I need to just ask a little bit on the interviewer side, like which of this, maybe like you said, like the fault tolerant will probably not the one that I should have touched on as well for the non-functional requirements. And then maybe like just ask which one of this that we definitely like the highest priority in terms of non-functional requirements.
Exactly. Excuse me. Yes, and to do that, right, we have limited time, so to volunteer both the kind of entire building blocks like you did, and to try and go through all non-functional requirements, that would be pretty tough. So what I would recommend is when you have, for example, a few of the building blocks like user, transaction service, server, and maybe one of the databases, like 3 or 4 of those main components, that's a good stopping point where you can make sure that you're covering some of your non-functional requirements.
Gotcha. So maybe after like this, I draw these diagrams, then I'll just go through each of the functional requirements and see which one that like I will probably try to make it even more, I guess, fulfill the requirements in the functional requirement.
Yeah, I think that's a good strategy. And one reason though, in my case, right, interviewers will differ. I didn't really interrupt you because I like the flow and I wanted to see more of a test on breadth for this interview. So that's why I didn't stop you and say, hey, tell me more about this. But it's kind of toward the end that I started, asking about load and load balancers. So in that sense, I think you did well. And that reminds me, actually, when talking about load and load balancers, one thing that I think would get a lot of bonus points for an E5 is that if you talk about not only the max, let's say queries like in a day or like max storage, but let's focus on queries briefly, is if you could focus on the percentiles, right? To say like, okay, in a given hour of, let's say, 9:30 a.m. to 10:30 a.m., I have an idea what my max queries in that hour will be, but let's think about the P99, P95, or P90. Those types of percentile discussions when talking about load, I think will get you a lot of even more positive signals.
Gotcha. Just basically is that we talk about that maybe in terms of the calculation part.
Exactly, and the way you started was perfectly fine in my view for an E5 is, okay, let's talk about max, and for example, storage, yeah, allocating some max storage is perfectly fine, but the percentiles become a little bit more critical when we're talking about throughput and like how much compute or nodes we might need in a given peak hour. Gotcha. Yeah, so that's when percentiles can be good to talk about.
Okay. So basically then from there we can calculate like how many instances that we might want to divide them from based on the P99 and then P90, then we'll have this. So we can just like talk about scheduling between the 90 to 99 based on those times.
Exactly. And in my view, I was, kind of satisfied with that. Like I didn't press you on the server, like how many nodes do we need in the server? Again, because for today, I kind of wanted to focus on breadth. But once an interviewer starts saying, hey, tell me more about load or load balancer, then that's a good opportunity to maybe go into those percentiles.
Sounds good. Yeah, thank you. Thank you for the feedback. Yeah, I think that's like really, really good tidbits there. Yeah, and I had a really good time with these interview questions.
Yeah, definitely. I hope you enjoyed it, and I like this question a lot. It's not too common, I think. And last thing I'll say is just for general practice, if you look at some of the so-called showcase interviews on this website, you might have seen them, but there's a few pretty good ones. There's one guy that really likes the food delivery app question, and that's another good one to practice with. But I think he's asked that question so many times, I wanted to make sure to ask something else. But anyways, if you want to look at a complementary problem, you can look at those as well.
Yeah.
But otherwise, it was a real privilege to speak with you today, and thank you.
Yeah, thank you. Have a good day too. Thank you very much for the interview.
Of course. All right. Thank you. Bye.
Bye-bye.